Hello and welcome. Let's go over set analysis fundamentals. Set analysis is an advanced aggregation feature in Qlik. And obviously it's one of the most powerful features at your disposal as Qlik designer or developer. So let's understand various components of set analysis before we dive into the syntax. I'll give you a warning, as a beginner, you may get intimidated by the set analysis syntax, which is a little bit complex to understand to begin with, but if you follow these lessons, you should be able to write set analysis syntax with ease. Once you understand various components and how to use them in your expression, it shouldn't be as hard or as difficult to create pretty powerful set analysis syntax or expressions. So let's begin with the components. There are three components. First is set identifier. So if you think of set is a subset of the data set you have in your document, and that subset has to have an identifier, essentially a boundary of the subset, and that's what the identifier is. And then there is an operator. So operator allows you to interact between different sets. So commonly used set operators are plus, minus, intersection, divisor, etc. And of course there is a modifier, which is one of the most important components of set analysis syntax. And it's like a filter in your SQL statement. So it allows you to filter values that you would like to filter. So with set modifier as a Qlik developer, so normally in associative model, when user makes selections, values get filtered based on the association among different fields, and that's based on the possible value. But with modifier, you can force expression to filter on certain values, and we'll see some examples as we go through this lessons. Now let's look at a typical set analysis expression. And as I said, it looks a little scary to begin with, but once you get hang of it, it's quite easy to understand and use. Remember, set analysis is an advanced aggregation feature, and it only works within an aggregation to begin with. So you have to have some sort of aggregation function, such as sum, average, etc., to use set analysis syntax. It will not work outside of aggregation function. So that's rule number one. Set analysis syntax starts and ends with curly braces. As you see within sum, you have curly braces on the left and curly braces on the right. So the outer curly braces are for the record set. Now within the set analysis, we have an identifier, which is $, which means default selections or default state. And then we have angle brackets, the left and right angle bracket that indicates the beginning and end of a modifier. And within the modifier, there's always an equal sign. To the left of equal sign is a field name. It has to be a field name, always. And on the right side of the equal sign are the values that you're filtering on. So in this example, we're calculating sum of sales for a salesperson whose name is John Doe. The expression will always calculate sales for John Doe. So this is how, as a developer or designer, you can force chart to render sum for specific filter value. In this case is John Doe. Let's look at some more examples. So first component is the identifier. So these are the various identifiers you can use. Mainly $1 and $, are commonly used. $1 and $_1 are there, but I have seldom used them. So 1 represents full set. So when you use 1 as an identifier, that means you want to consider entire data set. $, means the default or current selection. So it will honor selections made by your users. Now let's look at the examples. So at minimum, every expression that you write has a set component. So for instance, when you type sum of sales, internally Qlik expression engine is adding curly braces with $sign. That means the current selection or default state. So sum of sales and sum of $sales within curly braces are exact same thing. They both render same value. If you put sum of one cell, that means it will ignore all user selections. And then you can go further and add a total qualifier. So one ignores user selections and total will ignore chart dimensions. So you have a chart with set of dimensions and then users are making selections. So if you want to ignore both user selections as well as chart dimensions, then you combine one as an identifier with total as qualifier. It's shown in the bottom expression on top right. Now let's look at some of the operators. So union in a classic set theory combines records from both sets. Exclusion means it returns a set of records that belong to the first set but not to the second set. And then intersection obviously renders record set of common values between two sets. So some of the examples. So union in this example shows category name of seafood. If user makes selections on various categories, and even if user exclude seafood as selection, this will include seafood as selection along with other selections that user has already made on that field called category name. Now let's look at exclusion. So with minus equal, if user made selection on a field called category name, and if user selected seafood along with other values, this modifier will exclude seafood. So it will force the aggregation to exclude seafood while calculating the value. And then intersection means if user made selection on several values along with seafood, then other values will be ignored but seafood. So it will only include seafood as category name. So let's look at some of the examples. So here, first example shows count. Now that's again an aggregation function of patient ID. And we have start and end curly braces, the outer curly braces that indicate the beginning and end of the record set within set analysis expression. And then within the angle bracket, we have modality as a field on the left hand side of the equal sign, and on the right hand side we have set of curly braces that indicate element set, and the element set has a string value of radiology. So this will count patients with modality that equates to radiology, and one as an identifier indicates that this expression will ignore all user selections. So it doesn't matter what user selects, the values will always be counted for the entire data set. Then in second expression, we have dollar as an identifier. That means it's going to respect user selections. And then we have a couple of modifiers. So we have one filter that says year equal 2000, comma, region equal, and then we have a whole bunch of values. So this two filters will work in AND mode. It will read year equal 2000 and region equal several values. Now those values within regions are in OR mode. So you can read that as region equal US or SE or DE or UK or FR. Comma separates two fields and they're acting in AND mode, but the values within a specific field are in OR mode. So again, it returns the cells for current selection, but with new selection both in year and region. Now this is an interesting example. Here, this is an expression search, which is very powerful. So with this, it says select any year that begins with 2. So let's say year 2000, 2001, etc. And the last expression shows operator that you can use within the modifier. So if you want to exclude year 2000, for instance, or decade of 1980s, but you don't want to include 2000, so you exclude 2000 from the series of 2000. So it will start at 2001 all the way to 2018, and it will also include 1980s while calculating cells. And of course it will honor user selections because identifier is dollar. So let's go over some rules to reinforce what we learned. So within the set modifier, you can use string value, and string value requires a single code. Numeric values do not require any code. So for example, order ID equal 1001. Of course, it has to be in curly braces. the element set within the modifier requires curly braces. And the expression search always requires double quote. So the first example shows year is greater than or equal to 2011. So it will include 2011 through 2018. And you can also use a pipe, which is an OR operator. So it says 2009 or 2001, 2010, 11, all the way to 18. So again, a string requires single quote, numeric value doesn't require any quote, and a search requires double quotes. Okay, so let's review some concepts. One of the important concepts to understand is the modifier itself has sets on both sides of the equal sign. So we notice that modifier starts with angle bracket and ends with angle bracket. And within that we have a field name, equal element set. What lies on the left and right side of the equal sign are two sets. And equal is not in a literal sense. It's really an association of possible values between two sets. There are always two curly braces. The outer curly braces are for the record sets, and the inner curly braces are for the element sets within the modifier. The angle bracket indicates start and end of modifier, and literal values need single quote, search string requires double quote, and numeric values requires no quotes at all. And there is a so-called mixed state. That means record set can be in a default state, while element set can be in another set if you use an alternate state. So that was a quick review of set analysis. It's very powerful and one of my most favorite features in Qlik Sense. So what we're going to do next is to dive into some hands-on examples and of course challenges, so that you can try set expression and master it as we go along this chapter. Thank you for watching, and I'll see you in the next lecture.